Hello, algebra students. Okay, so what we're doing over this weekend is, I know it's a long weekend, but this is a short, it's an eight question quiz. You have all weekend to do. This is not going to be taking a very long time, okay? But I just want to go over the directions with you. So this is what I'm going to do. So first two questions are, well, first thing, no decimals. So anything you're doing from here on out in this test has to be in radical form. I don't want to see a decimal. You have to simplify things, but you cannot plug it into a computer and do or a calculator and give me decimal forms. Square root of 34 is a decimal. 32 here is a decimal if I put this in the calculator, but I'm not going to do that. What I'm going to do is simplify it. And by simplifying, I mean I try and make it as simple as possible. I look at this and I think of my perfect squares, right? 100, 81, 64, 49, 36, 25, 16, 9, and 4. And I ask myself, well, which is the smallest one, the biggest one that goes inside of 32, and that would be 25. Now, once I got that, then my next step is find my calculator. Hold on one second. I can't believe I forgot my calculator. Okay, so with my calculator, I'm going to go through this. I'm going to start taking these numbers and work my way down. So I'm going to do 32 divided by 25. That's a decimal. Don't want to do that. 32 divided by 16. That worked out pretty quick. So 32 is also square root of 16 and square root of 2. Well, square root of 16 is one of my perfect squares. 6 to square root of 16 is just 4. It's a whole number. Square root of 2 is a decimal. And it's small. There's no perfect square. There's no one of these perfect squares that fits here except 1, and we can't use 1. Or square root of 2. That is how you do the first two questions. Something along that method. Use this as a cheat sheet as well, not just directions. Next one. You got something like this. This is my example, square root of 36 over square root of 49, and I realized something about this. It's the same as that. Square root of 36 is a perfect square. We remember from our list of perfect squares. I'm going to have sticking out over here. Square root of 36, 6 times 6 is 36. Square root of 49 is also another perfect square. Do you see two perfect squares here? All right, next one. Simplify the following radical. Now you look at it and you say, well, square root of 11, there's nothing I can do with it. Well, let's look at another one where square root of 5 is another problem where I can't do anything with square root of 5. 5 divided by 4 is a decimal, so it doesn't work. But the rule is you cannot have a radical or a square root on the bottom or denominator. So I got to fix this. How do I fix it? Well, that's pretty simple. I'll take the original problem. I'm going to multiply it by 1. Well, any number multiplied by 1 is itself. So I'm going to use the special one. Square root of 5 over square root of 5. And look what happens. 1 times the, I'm using the same number. 1 times the square root of 5 is, well, square root of 5. Now on the bottom, square root of 5 times the square root of 5, it's just 5. That's it. That easy. Next step. 10 square root of 3 minus 6 square root of 3 is my example. But I give you 5 and 6 very similar. So follow along. Well, this is what we can call combining like radicals. This is just like combining like terms. But instead of combining like terms, I have to make sure that these two are the same. Square root of 3 and square root of 3 are the same. This is just the same as if I said something like, give you an example, 10x minus 6x. Well, that would just be 10 minus 6, 7x. Same thing works in this. 10 minus 6 is, why did I say 7x? 4x, excuse me. 10 minus 6 is 4. Square root of 3, I just bring down. That's just a like radical. I don't do anything with it. Look at 7, 6, and 5 and 6. Now this is one problem. It's a little bit more difficult. It's like combining like radicals, but it's just slightly more difficult. They're not like radicals. So how do you make them like radicals? Well, if you simplify one of them, I can't simplify square root of 5. You do 5 divided by 4, the last of these perfect squares, and it's a decimal, so I can't do that. But I could do square root of 20. Maybe I could do something with that. Well, there's only a few options. 16, 9, and 4. Well, that's good. So let's try these numbers. So I'm going to do 20 divided by 16, 1.25. That is a fraction, no good. 20 divided by 9, 2.222 repeating, no good. 20 divided by 4, my last chance, I do get this. So I can rewrite this. 20 divided by 4 is 5. So as I'm going to rewrite it this way, I'm going to say 7 square root of 5 plus 2. Now, 5 times 4 is 20. Square root of 5 times square root of 4. Because 20 is square root of 5. 20 is 5 times 4. Now, square root of 4, I can't figure out. The square root of 4 is a perfect square from our list. Square root of 4 is 2. So I go 7 square root of 5 plus 2 square root of 5 times 2. Now I can multiply the coefficients, and this here, 2 times 2 is 4. So 7 square root of 5 plus square root, plus 2 times 2 is 4 square root of 5. 7 plus 4 is 11 square root of 5. Here's another example. One more. This one, simplify the following. We're going to use a little bit of our good old distributive property. So I have square root of 3 times square root of 6 plus 4. Square root of 3 times square root of 6 is square root of 18. I just take these numbers and multiply the numbers on the inside. Plus, because there's a plus sign here, square root of 3 times 4 is just 4 square root of 3. No math needed. Now, next step. Square root of 18. Well, square root of 3 is smaller than 4, so I can't simplify square root of 3 anymore, but 18. Well, that has 3 options. I could use 16, 9, or 4. So let's try these options I have on here. My options are 18 divided by 16, decimal, 1.125, not good enough. 18 divided by 9, 18 divided by 9 is square root of 9 times square root of 2. Now, let's look at this again. Well, square root of 9 is just a perfect square. It's 3. 3 square root of 2 plus 4 square root of 3. I'm bringing this one down. Is there anything else I can't do? No, I leave this alone because square root of 2 and square root of 3 are not like radicals. They're different. 1 square root of 2, 1 square root of 3. Can't add them. This is my final answer. So look at that. That maybe you might be able to, I'm looking at this, I'm saying you might be able to combine like radicals here if you do it right. So work on this and make sure you don't leave any radical not simplified. Okay. Good luck, ladies and gentlemen. I will talk to you soon. Take your time with this. You have plenty of time to do this.